Everybody agrees that we must protect our environment and preserve it for future generations, starting with our children. Our children, whose health and well-being also depends greatly on the quality of our buildings. Here an alarming statement. A non-insulated building is responsible for 40 to 50% of our energy consumption and for 40 to 50% of our carbon dioxide emissions into the atmosphere. Here's what happens with wall without insulation. The solar radiation hits the wall that stores its heat and restores it into the inside of the building. Conversely, the air conditioning produces cold that will be let into the wall, which in turn will restore it to the outside of the building. That's what we call the thermal bridge phenomenon. So in hot or tropical climate, the building will be warmed by solar radiation and much of the cold produced by the air conditioning escapes to the outside of the building. An absolute nonsense. Outside insulated walls are not hit by solar radiation, but much of the cold from the air conditioning is still wasted and driven out. The phenomenon of thermal bridge is thus attenuated. With double insulation, outside and inside, the solar radiation does not warm the building and the cold produced by the air conditioning is trapped inside. This ideal building does not know the phenomenon of thermal bridge. The ultimate goal is to move from a passive building, that is to say, with high energy performances and that does not require heating and air conditioning, to buildings that produce more energy than they consume. In this perspective, three essential rules must be respected. First, removal of thermal bridges. Second, have walls with high thermal inertia. Third, build airtight buildings with controlled ventilation. Thermal inertia and airtightness, two areas in which the concrete walls are most efficient, better than the brick walls and of course the walls made out of wood, materials without any thermal inertia and absolutely not airtight. Here's a dynamic simulation and a study of the potential of energy savings in air conditioning carried out on buildings located in tropical climate. The chosen geographical location is the city of Chonburi on the shores of the Gulf of Thailand, quite representative for any tropical climate. We see fairly uniform temperature throughout the year, with a maximum of 37 degrees in April, a minimum of 18 degrees in December, and an average annual temperature of 28 degrees. Vertical solar irradiance is uniform throughout the year. All the data of the buildings were taken into account, namely the insulation coefficients of the opaque elements of the envelope and their contacts with the ground and the air, the insulation coefficients of glazed elements and their percentage in the envelope. Two types of buildings have been studied. The first one, 10 per 10 meter house with a flat roof on 3 meter high. The second building, 10 meter on 7.5 meter house on 2 level with a flat roof 6 meter high. And their operating data. The thermal loads of its occupants, appliance, ventilation and so on. All that for a target comfort temperature between 20 and 26 degrees centigrade. A first simulation of typical building makes it possible to identify the improvement potential of the various elements of the envelope according to their thermal resistance and their respective surfaces. The greatest potential for improvement lies in the facades and in the roof. For our example, we will take the type 1 building, meaning a house 10 meter on 10 meter, flat roof and walk-in. It is clear that without any insulation or air conditioning, This building does not consume any energy. Without insulation but with air conditioning, it will consume 100 watt per square meter or 24-liter oil equivalent per square meter. The insulation of the flat roof will lead to a significant improvement and lowers its energy consumption by 32 to 34%, depending on the thickness of the insulation and therefore its insulation coefficient. The insulation of the facades will also contribute to these energy savings by 25 to 26%, again depending on the thickness of the insulation and its insulation coefficient. The insulation of the floor will reduce this consumption by 6%. The combinations of its insulation elements allow an energy saving between 57 and 65%. Free to the builder or the owner of this building to choose the most relevant combination for its comfort and for its budget, according to the ratio between the investment that the insulation represents and the energy savings on the medium and the long term. In summary, a 4.5 cm outside and inside insulation reduces energy consumption by 25%. A double thickness of outside insulation, that is to say 9 cm, is not significantly more effective. Insulation of the floor contributes only to a small extent because of its contact with the ground. The combination of the insulation of the roof and the facade allow a saving about 60% for a maximum temperature of indoor comfort between 25 and 26 degrees, and the energy consumption of the air conditioning is divided by 3. An uninsulated building needs 10 kW of air conditioning, a properly insulated house only 2.8 kW. With an energy efficiency index 4 air conditioning system and an indoor and an outdoor temperature difference of less than 14 degrees, this consumption drops from 2.5 kW to 0.7 kW. In other words, this building will be able to be air conditioned with the equivalent of the consumption of your hairdryer. For this climate, Euromac 2 offers a 25 cm thick block with 4.5 cm inside and outside insulation and a 16 cm concrete veil. They assemble dry, without glue or mortar, at a rate of 1 square meter per minute, thus significantly reducing labor costs and allowing to go up and pour a floor every 3 days. The dovetail profiles ensure perfect contact and hold between concrete and insulation, between insulation and plaster or coating. The integrated steel structure gives them optimal strength and easy steel reinforcement placement. Floor-level poured concrete offers excellent thermal inertia, airtightness, and optimum sound insulation. The complete range of Euromac 2 blocks adapts to all climates and uses, depending on the desired thermal coefficient. Euromac 2 is the unchallenged leader for buildings with high energy performances. Euromac 2 is actively looking for a partner for the manufacture of its product in Southeastern Asia and offers exclusive distribution on the partner's territory, the complete real-world test of machinery and equipment before delivery, collaboration for the market approach, its parameters and local potential, advices for sales techniques, a presence on the internet, marketing and communication, the management of sales forces and logistics, technical assistance for customers, assistance for local certification and regulations, long-term commercial and technical support. Euromac 2 expects from his partner the creation of a local legal identity, a business reference plan, a production unit of more or less 800 square meters on the ground and a useful height of 6 meters, The annual production of blocks of 25 or 30 centimeter on 1 meter for 50,000 square meter of wall, equivalent of 3 to 500 housing units. An investment for the manufacturing unit of 1.5 million euros or 1.7 million US or 39.6 billion dongs. Management of local elements, terrain, infrastructure, regulation, administrative aspects, etc. Active marketing in his territory, royalties on production. Euromac 2 today, a design and customer support team, a registered training center, R&D in partnership with EPFL, Polytechnic University of Lausanne in Switzerland, more than 100 employees, 20 million euros in annual turnover, up 50% every year, one of the 60 best SMEs in France, factory direct sales to professionals and private customers. Euromac 2 is the leader in passive construction and high energy performance for residential, commercial and industrial buildings, 40 years of innovation and experience, 40,000 constructions completed, more than 1,500 projects a year, the only manufacturer to offer a global wall, roof, slab solution under German Passive House Institute certification. For any contact, please contact Mr. Philippe Lurian in Switzerland. There you see his mail address and phone number. So we thank you for your kind attention and hope to hear from you very soon.